Hey everybody, I got a lesson for you today about vertical motion explained by parabolas. Okay, so the height of objects through the air can be represented using a simple mathematical equation. And here's that mathematical equation. I hope you think it looks simple. H equals negative 16t squared plus vt plus s. What in the world does that mean? Okay, so this equation's job, so to speak, is to tell you the height of something if you know how long that object has been in the air. Now, there are lots of factors that affect this. So if I throw something in the air, how hard did I throw it? Where did it start from? Did it start from at the bottom of the Grand Canyon or on top of a skyscraper, or where? So that's why the formula has the v and the s in it. In order to use this formula, you need to know two things. When I launched or threw my object, what was its initial velocity and what was its starting height? So let's take a look at this basketball player here for a second. There's a difference between this shot and the shot of someone who is shorter but uses the same trajectory. That's what would happen if you changed the s value, or the starting height. The other one is the initial velocity. So when the basketball player shot it, how hard did he shoot it? There would be a difference between someone shooting that hard, in this way that the basketball makes the hoop, and way harder when the basketball goes into the crowd. So you're going to be given those pieces of information. So for example, your formula might be, say, this. H equals negative 16t squared plus 20t plus 6. The 6 would be the starting height, and that's going to be measured in feet. And the 20 is going to be the initial velocity, and that's going to be measured in feet per second. Now you may be asking yourself, well, that doesn't explain the negative 16. Well, the negative 16 is the gravitational constant, which is used in feet per second squared all over Earth. If you're in a science class, you might use numbers like negative 9.8 or negative 4.9. Those are for meters. That's a little bit different. All right, so we know those two things. We have been given that the height formula for this particular problem is h equals negative 16t squared plus 20t plus 6. We might want to know how high off the ground the ball is at a half second. So a half second after the basketball player shoots, how high off the ground is the ball? So we would take our information and we would say, well, 0.5 seconds, that's a time. So what we've been given is we've been given a t equals 0.5, and they're asking us for an h. How high is it when t equals 0.5? So we're going to take our formula and we're going to fill in what we know. We're going to do 0.5 squared and then multiply by negative 16. We're going to do 0.5 times 20, and we're going to add 6. Okay? This is really straightforward. I will say that this part, the 0.5 squared, that needs to come first because that's an exponent. So make sure you do that before you multiply by negative 16. Okay, so I did all those calculations, and I got 12 feet. So it looks like at 0.5 seconds, the ball would be 12 feet off the ground. So maybe that would be like here, just a little bit taller than the basketball hoop. Sounds pretty reasonable. Okay, so we're going to move on to another problem. A diver jumps from a 33-foot rock with an initial velocity of 2 feet per second. The equation that models this situation is h equals negative 16t squared plus 2t plus 33. Notice that the diver starts and goes up a little bit and then comes downwards. So we want to know how far above the water will the diver be after 1 second. Well, we've been given a time, t equals 1, and we need to find a height. So we're going to plug that into our equation. Negative 16 times 1 squared plus 2 times 1 plus 33. And you can punch that out in a calculator, or you can use your head. Either way is fine. And what we're going to get is 19 feet. So after 1 second, the diver is 19 feet off the ground. Seems reasonable. You know, maybe that's like right here. Now the next question is, will the diver have hit the water after 2 seconds? So the t part is pretty straightforward. T equals 2. But the height part is not so simple. Let's come back to that in a second. Let's just do the calculation and then see what happens. Okay. So the first thing we're going to do is we're going to plug in 2. Once again, you have to do the squaring part first because of PEMDAS. The exponent comes first. And when I do that, I'm going to find that the diver is supposedly at negative 27 feet. Well, negative 27 feet would be under the water. So it seems like the diver must have hit the water at some point that was before t equals 2. So will the diver have hit the water after 2 seconds? Yes. All right, our last one. If a rocket is launched with an initial velocity of 108 feet per second from 1 foot off the ground, when will it land? Assuming it doesn't have a parachute. Now, when we're just starting off with algebra, we have to take a lot of things off the table. So we're not going to be doing anything with wind resistance or anything like that right now. We're just going to do a very, like a model problem. Okay? So I filled out the equation for you. At some point you will be expected to fill out the equation yourself, but I just plugged in the 108 for the velocity and the 1 for the starting height. So first, what are we trying to find? It says, when will it land? So the rocket is going to go way, way up really fast, and then it's going to turn around and come right back down. So we want to know, when's that going to happen? When will it land? And later on we'll go and we'll answer questions about like, well, how high did it go and things like that. But right now, just when did it land? So what we're trying to find is, when will the rocket land? That means t is our unknown, which means we must have to know what the height is. What's the height? What's the height? So what information does the problem provide that's hidden? Well, we already know what the height is going to be at the end. It's going to be h equals 0, because it's going to be back on the ground. It's going to end up 0 feet off the ground. Okay, so that means h equals 0, so we're going to change the h from the equation into 0. And as I'm looking at this, I'm thinking I'm going to use the quadratic formula. And my reason for that is because it looks like I kind of have nasty numbers. They're very big, and I'm probably going to end up employing a calculator. If I'm going to end up employing a calculator, I think I'll probably use the quadratic formula. So my a is negative 16. Remember, that came from gravity. My b is 108, and my c is 1. I'm going to plug that into the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to get two answers here. I'm going to get 6.75 seconds and negative 0.009 seconds. Now, last time I checked, we don't have a time machine, so it can't be negative time. More on what that means later. So that must mean that it's going to take 6.75 seconds. Make sure you can get that out of your calculator. That's definitely something that everyone would use a calculator for. Okay, so there are going to be some practice problems for you to do, but this is a kind of a start for you. All right, thanks for watching. I hope you enjoyed the video. I know I certainly had fun recording it. Remember to subscribe and such. All right, see ya.